Hi, I'm Dan Zanoble, and this is my submission for ENPM701 Homework 9. For this assignment, I was required to create a script for the robot to autonomously track and retrieve an object in a cluttered environment and send an email once complete. The final script uses data from the camera, the IMU, and the encoders to perform this task. I chose the blue block as my item and used the provided color picker script to find optimal HSV values. I wrote a script that continuously displays the camera view and used the OpenCV, Find Contours, and MinArea Rect functions to display a box around the tracked object. I created a function called Object Tracker that displays the camera feed and continuously updates the pixel coordinates of the center of the tracked object. I created a thread for this function so that it continuously runs in the background. I also created a serial thread function and thread that continuously updates the current orientation angle of the robot based on the IMU data. To orient the robot towards the object, the rotation target is continuously calculated from the center pixel coordinates, and the robot turns until the rotation target is 0 plus or minus 2 degrees. Based on a 38.88 degree field of view spread out horizontally across 640 pixels, it is known that each pixel contributes 0.061 degrees. Therefore, the angle change required to center the object can be calculated by horizontal distance from center line times 0.061. I ran into issues with the robot overshooting the angle and entering a loop where it would keep oscillating back and forth trying to reach the target. To counter this, I turned the robot in steps, with the time increment between the steps decreasing as it gets closer to the goal. There's a tendency for the robot to rotate back a little after it stops, so a delay was introduced to ensure the position was stable before continuing to the next step. Next, the robot moves forward to the object. A control loop uses IMU data to ensure the robot travels straight. The travel distance is calculated from the encoders and stored for later use. Testing showed that when the block is between the grippers, the pixel Y position is around 420. For the initial forward motion, the robot moves until the pixel Y position is 350, then it recenters the object in camera to correct for error. Next, the robot inches forward at 0.1 second time increments until the Y pixel coordinate is 420. At this point, the block should be between the gripper jaws. The gripper closes, opens, and then closes again. This makes sure the block gets trapped correctly, as sometimes it can get tilted in the jaws of the gripper, which leads to issues. To avoid having to worry about rotation clearance around the other objects, I just had the robot reverse back to the starting point. The travel distance and initial orientation are used to ensure it returns correctly. Then the robot uses the IMU data to turn 180 degrees and opens the grippers. Finally, an email is sent indicating the object has been retrieved.